Okay, so now we will draw the diagram of the compound microscope. So as usual, the ray diagram for the compound microscope, as usual, we draw our principal axis, right? Now, we must remember that the focal length of the objective is less than the focal length of the eyepiece. For our convenience, let us take the focal length of the objective as 2 centimeter. Okay, we'll take it as 2 centimeter, right? And now what we'll do is, first we will place our lens over here at this point, right? At this point, let us place our lens. Okay. Okay. Now what you do is, from here at a distance of 2 centimeters and this side 2 at a distance of 2 centimeters. Okay. This is my focal length of the objective. Focal length, first focus, right, of the objective, right? Now my image should be placed just beyond the focus. So for my convenience, once again I repeat, it is only for my convenience, okay, I take it at a distance of 3 centimeters, right, from here, just for my convenience, and I take a small object. Don't take a very large object, otherwise the image at the end will come very big and it will go outside your paper which you're going to, your board paper which you're going to, right? Now this is my object AB. This is my object AB. Okay. Now what you do is, the first thing you do is you draw a line parallel to the principal axis. You draw a line parallel to the principal axis. Okay. And let this line pass through the focus. Let this line pass through the focus. Right. Now, the second ray of light directly passes through the optical center, and it does so without any deviation. It does so without any deviation. Correct? It does so without any deviation. Now here is where my image is formed. Here is where my image is formed. Right? My first image. This is my A dash and B dash. Right? Now what happens is, this image should lie within the focus of the second lens of your eyepiece. So for our convenience, right, we will remember this 0.5 centimeter. Okay, this makes the diagram a little easier, right? So this is my 0.5 centimeter. Okay, and then I will obviously take 3 centimeters and another 3 centimeters. Is that clear? So this is where my lens will be. Okay, this lens is bigger than the objective. My eyepiece is slightly bigger than the objective, right? The focal length also is larger, right? This point of mine is my focal length of the eyepiece, and this is also the focus of the eyepiece. This is also the focus of the eyepiece, right? Now, my ray of light comes parallel to the principal axis, okay, and it passes through Fe, and my second ray of light passes directly through the optical center. Can you see both these rays of light diverging away from each other, moving away from each other? So in order to obtain the image, I have to produce the rays backwards, right? I have to produce the rays backwards. With a dotted line, right? So that's where, wherever these two rays of light, dotted rays of light, they meet, that's where my image is formed. That's where my image is formed, right? So here I'm getting them meeting over here. This position is not so important, right? But we must know that we get an enlarged image which is inverted with respect to the original object, but with respect to A dash B dash it is not an inverted image, right? Correct, it is not an inverted image, right? Now I'll complete the lenses just to make my diagram more perfect, right? I'll just draw the lenses in order to make my diagram more perfect, right? So here okay, and this is my second lens. I can use a protractor, I can use a compass, I can use anything I want in order to draw this.